Okay, so hi everyone, I'm Dimitris Kolovos from the University of York, and today I want to talk a little bit about a product of the lockdown. So something we implemented over the last 9 months, roughly, and it's the Epsilon Playground. So some of you will already be familiar with Epsilon. It's an Eclipse project. It's an open source project, and it provides a family of scripting languages for common model management activities, things like model-to-model transformation and code generation and model validation and so on and so forth. Being an Eclipse project, Epsilon has kind of strong links with the Eclipse platform, and all the development tools we have been providing so far, things like editors and debugging facilities and run configurations, etc. They've all been Eclipse based. So over the last couple of years, we've been trying to support additional platforms. So we put a lot of work into making Epsilon executable from standalone Maven and Gradle builds, so that you can run a code generator, or a model validation script from a continuous integration script, for example, without using Eclipse at all. And in this direction, the latest kind of part of Epsilon is the Epsilon Playground. So this is essentially a web application that allows users to write and execute Epsilon programs directly from the browser. So using the Epsilon Playground, one can create meta models using eCore and its emphatic textual notation, models using another textual notation I will talk about, and then also write programs in Epsilon's languages, and then execute these programs straight from the browser. In terms of the technologies we have used to develop the playground, we've built extensively on kind of high quality open source components like the ACE editor. So this is the editor you see here. It's very widely used. It's very configurable. You can define syntax highlighting rules and so on and so forth. Very scalable as well. Metro UI, which provides the overall framework of the navigation bar, splitters, panels, buttons, and so on and so forth. Also a very good, very powerful framework. And then D3 GraphViz, which is essentially a port of the GraphViz software that most of you must be familiar with for drawing graphs, to WebAssembly and JavaScript, which allows you to essentially render graphs, transform text-based graphs into kind of nice pictures. Of course, because Epsilon is Java-based, execution of the programs against the models cannot happen in the client, and I'm going to talk about this a little bit more. So we need to send the program, the model that it runs against, and its meta model to a Java server. Execution happens there, and then we get the results back in the client, and we render these. And for this purpose, we have used the Google Cloud Platform, and in particular, the serverless functions part of it. And all of this is currently available under eclipse.org/epsilon/live. So just go, I'll stop with the slides now, and I'll just do a very quick demo. So this is what the Epsilon Playground looks like. You can see here on the left-hand side, there are a number of examples. Some of them exercise the Epsilon object language, which is the core language of the platform. Some of them contain validation constraints, model-to-model transformations, model-to-text transformations, etc. So this first basic example, it shows a small project scheduling meta model. So this is the meta model. It's expressed in emphatic, which is a textual syntax for eCore. I'll click on this button, and that will render the meta model as a diagram using GraphViz, the JavaScript port of GraphViz. So, so here you can see how a project contains tasks, and then every task contains effort from different people, putting different percentages of their time on every task. And here we have a model in FlexMI. This is a kind of flexible textual notation with an XML-based and a YAML flavor. Here we have the XML-based flavor, and we can see how we have a project, and then 2 people contributing to it, and then 3 tasks and some effort that goes into that. Again, to make such models easier to read, there's another function that turns that into an object diagram, so you can more clearly see the 3 tasks and the 2 people, and so on and so forth. All of these representations are editable, so I could go in here and say that, well, there's another person, which is called Charlie, and then if I refresh my diagram, you can see Charlie over here. So all of these are editable. Okay, and of course the main function of the web application is to be able to run programs against this model. So here we have a program that will iterate through all the tasks of the model, and then it will print the title of its task, and then the total effort, which is computed through a function here. If I run this, that's going to take a few seconds to execute. That's because the Google Cloud Platform, and in particular the function, the serverless functions feature, it activates, essentially it spins up a VM the first time the function is used. It keeps it there for as long as the function is being kind of actively invoked again and again. But then if no one invokes that function for some time, it kind of brings it down again. So next time you need to use it, it has a startup cost. So I've executed my program. I can see that I have 3 tasks with this effort, and so on and so forth. Okay, so this is the core language of Epsilon, EOL, which we can use to query models. And I'm going to show how we can validate models. So here we have, again, the same meta model, same similar model, but we have some constraints that we want to check against it. So we want to check, for example, that the duration of every task is greater than 0, right? So we do this using EVL, which is the validation language of Epsilon. I'll get rid of this for now. So if we run this, now we'll see that the validation will happen. And then what we get here is an object diagram of the model, of our source model, but we get some extra nodes here that show the different problems that these constraints reveal. So for example, the duration of this task is not positive. So if we look at the duration here, it's 0, right? Very similar for model to model transformation. So here we transform projects and tasks into projects and deliverables. The idea is that for every task we need to have one deliverable, and whoever contributes more to the task will be the deliverable leader. So here we have a model-to-model transformation in another language of Epsilon called ETL, the transformation language of Epsilon. Again, we can run this, and that will produce here an object diagram of the target model. Again, we can modify the transformation, we can execute, and so on and so forth. Finally, I want to demonstrate the model-to-text transformation language of Epsilon, EGL. That's a template-based language. Let's have a look at this transformation. So here we have a model-to-text transformation that effectively emits HTML. So here we have some static HTML, and then we try to emit a table with all the people in the project and all the tasks in the project, and then all the effort that every person puts into a task. So same story, meta model here. If I execute this, that will generate HTML, and it will also kind of render it in the browser. Which means that now we can use all sorts of web-based frameworks. We can use, for instance, Google Charts, and instead of such a table, we can generate a nice pie chart, right? And none of this is hard-coded into the playground. This is the template that brings in the Google Charts library. What else? Yeah, so we can generate text, we can generate HTML and render it at the same time, and we can also generate, what is that? We can also generate graph trees. So if I execute now this template, this CGL template, this model to text transformation, you can see how I get how I get nodes for every person and then nodes for tasks. So effectively, what is generated by this transformation, if I uncomment this line, it's just standard boring graph trees code, but then that gets rendered using D3 graph trees. A nice feature of the playground is that you can create your own example, right? So if you wanted to add Charlie here, that's Charlie, and then I'll try to run this, see that Charlie pops up here. Now I can click on this share button, and that will create a short link. And then if I put this in the chat, you're able to go there and actually access a copy of this example. So you can create transformations, you can create kind of small exercises, and then share them with newcomers, with students, etc. So that's my live demo. I'll just quickly go through a couple more slides that I have. So what did we learn during the development of the playground? I spent a lot of time trying to convert the Java to JavaScript. Apparently, this is a thing. There are libraries that can convert compiled bytecode to JavaScript or WebAssembly, and then you can run them on the client. In theory, I found that none of them was kind of powerful enough to properly translate all the Epsilon jars. So it's not a solved problem. If you want to get rich, solve this problem. There's a lot of demand for kind of moving legacy applications to the web. None of the existing solutions work perfectly. Another thing I learned was that Google Cloud Functions are very straightforward to use. So you can deploy REST type services on Google Cloud with very little effort, and they provide a very good development kit. Essentially, the whole of the backend is a Maven project that you can run and debug locally, and then when you're done, you just push a button and it gets deployed to the Google infrastructure. Really good. And also, I was surprised to find that it's very inexpensive. So we get about 1,000 invocations of the various functions per month, at least for the last couple of months in the Epsilon Playground. And the cost for that, our bill is about 10p, so 10 pence per month. And most of it is actually the cost of the storage, because every time you click on the share link, a copy of your transformation and everything gets stored into a blob so that we can retrieve it next time you visit that link. So if you want to charge us lots of money, create lots of examples, and we'll see our bill kind of growing. And then in terms of usage, I've found this to be very useful for teaching. So I taught a course at L'Aquila at the GSSI last week, and I would normally teach this course using Eclipse, and students would spend half of their time fighting Eclipse until they could get anything to run. Now you just share a link, they just do their thing. And that's good. It has also been very useful for issue reporting. So when a user comes to the Epsilon forum and says, well, I'm trying to run this transformation or that, and I'm getting this exception, create a small example on the playground, send us the link. We have everything we need to debug. And also, we haven't made full use of it, but it's quite good in order to provide kind of executable documentation. So that fit different features of the language. You create a small example, put a link on the documentation website, and that's it. So next steps, it would be nice. So when you have your example here, yes, you can share the link, but it would be nice if you could also download the example as an Eclipse project or a Maven build or a Gradle build, and we have all this information in the kind of in this environment. So this is just a matter of actually getting it implemented. Right now, this is a kind of Google Cloud thing. The source code is stored in a Google repository. So if you wanted to run a copy of the playground at the moment, you can't. And this is something we want to change. We want to make this fully containerized so that you can spin a Docker container and get it running on your own infrastructure. And also ACE supports live collaboration, kind of out of the box. You just need another server that does the live collaboration thing, and it would be really nice to do this for kind of collaborative exercises, particularly between students. And that's me. Thank you very much.